Good morning. Thank you all for making it. I hear there were a few fun disruptions with traffic and trains and planes and everything else along the way. So really appreciate you all making it. Like Duncan said, my name is Bhashyam. I lead all of our customer solutioning teams at C3 AI. I've been with the company now, I think 8.5 years, going on about 80. It feels like that at least. And prior to that, I was with McKinsey for 12 plus years in various sectors, and I'm a computer scientist by training. I've had the fortune of living this journey not just at one place, but at 50, 70 different customers of ours as we run them through this process of starting with one use case, trying to figure out what to do, get value from it, and then help to scale. And it's a very inspiring journey because you see companies change, you see people change as you get into that process with the aid of technology. The key, though, is ultimately this becomes a people sport, right? You're assisting or enabling processes with the aid of technology and not replacing them. So really thinking through that process and really thinking through how that plays out is key. Let me give you a little flavor, hopefully this works, on what we do. At C3 AI, our entire focus is on achieving or helping with business processes. So what does that mean? Well, it means really applying AI, machine learning, optimization algorithms on massive amounts of data to solve business problems. And those business problems look like this. If you're in the process production world, this looks like predictive maintenance. It looks like yield optimization. So how do you manage a stochastic process with the right inputs to maximize yield in a variable world? It means energy optimization. So how do I benchmark and then draw down the amount of inefficient use of energy so that you can drive down a cost effectiveness or otherwise? In the supply chain world, this looks like inventory optimization, constantly and dynamically running machine learning and optimization algorithms to decide how much of anything to carry at what locations on any given day to reduce working capital and maximize availability of spares, availability of raw materials, what have you. We're seeing a lot of work in supply chain, in sustainability, et cetera. And all of our deployments have tended to be large strategic plays at our customers. So you'll hear from Richard shortly about Shell. I won't spend too much time on it. At Cargill in the food industry, we're busy doing a lot of supply chain and process related work. So imagine all of their food processing plants in North America where there is variability of raw materials, right? How much you get, how much you're able to receive from your upstream suppliers. There are constraints on how long you can keep food processed on any given day, any given line. There are huge amount of constraints on what types of resources can act on what types of food, right? Just based on skills, specialization, et cetera. And our systems help schedule exactly what to produce every given day, taking into account variable demand functions from Cargill's customers. So you're optimizing the amount you produce to minimize wastage, maximize the capacity of the plants every given day, right? And this is now running in about 15 plants in North America, going to 30 by the end of the coming year. Shell is a multifaceted story. I won't get into it too early, but we'll take questions at the end after Richard speaks. At Koch Industries, we're active in multiple parts of the business, both in terms of predictive maintenance and equipment reliability for very large pulp and paper machines. So these things are the size of a football field or maybe 3 football fields. They're fully connected, soup to nuts. They're almost they're the they are the pulp and paper equivalent of a refinery, right? They're all just, it's just one big machine that starts from one end and comes out the other end. And we're helping Coke, Georgia Pacific, which is the Coke company that makes paper, on keeping the entire system working, doing root cause fishbone analysis dynamically as you detect a fault. Where is there an upstream event that could have caused it? We're now expanding into demand forecasting and supply chain optimization between plants. So how much should one plant make to meet the demand supply function of a second plant in order to go from there? We're doing supply chain optimization for market demand. So a lot of you in the chemicals industries need to decide, and petrochemicals need to decide how much to make, where to place it, what market spot rate to pick for what in order to trade, and so on. And we're working with one of the other companies in the Coke family called Flint Hills in order to do market-based inventory optimization. So where do I place, or where do I draw down from based on the market demand for the next X days on a continuous basis? And at Bank of America, we're doing a lot of work on what we call transaction monitoring. Imagine all of you as companies having business relationships with a bank. We're watching, where our systems watch the entire transaction flow, product flow, relationship flow between one of your companies and the bank in order to assess for things like revenue opportunities, churn prediction, things like that, as well as monitoring transactions in near real time, right, that attach the market. Now, the reason we're able to do all of this at the scale, and I think I want to underscore the scale of this. This is not science experiments. This is not one-off, let's prove this works. These are production systems working in mainstream processes, running as part of day-to-day operations, right? And to get to that point, it's an order of magnitude, maybe 2 orders of magnitude more complex in order to get through all of the pieces that you need to solve for. And the way we're able to do this is a combination of the technology that we have assembled over the last 13 years as a company, and also working very closely and collaboratively with our customers. Let me talk a little bit about the technology for a second. If you take any of these examples, I'm sure it's not lost on you. A large problem here is, how do I make these optimal decisions? And the way you do that is through the right amount of data and the right algorithm. Well, easy to say, hard to do, right? Because the right amount of data is all your systems in multiple places, sitting all over the place, different formats, different IT governance rules. How do you pull all of that together? How do you keep it continuously updated as these things change? Some of these data sources change at the rate of every second, or 10 hertz or 50 hertz. Some of these data sources change once a quarter or once a year, right? Some of these are done once. Your PNIDs for your plants are done once, and they're stored somewhere in a PDF file with no ability to use them unless you can pull them in. How do you use all of that information seamlessly? Huge problem. If you can solve it, that's the start of a very strong foundation to then go from there. Right? The other piece of this is, how do you dynamically serve up and continuously process this information to solve, let's say, monitoring 2,000 valves in a refinery, where every valve needs its own machine learning model. That's 2,000 machine learning models that you have to manage seamlessly and dynamically all the time. Right? And the third piece of this is, how do you then show all of that? Great, you can do 2,000 models or more. How do you show all of that information to someone who can use it to make a decision? Right? Should I intervene? Should I send a work crew? Should I change the production schedule? Should I order more parts? Should I call this supplier and say, why is your purchase order going to be late? I know it's going to be late. Tell me what you're doing about it. All of those are process decisions that you have to make on the fly as you run your operations. And in order to do that, we've spent a lot of time working through the technology stack that at the same time solves for this data problem plus analytics plus machine learning plus application capability, while respecting every one of your enterprise IT security requirements. right? Because we understand it's not straightforward or trivial to deploy software in an enterprise setting. There are considerations on where you do it, how you do it, what to use, what security, what lockdowns. And we've engineered the system so that we're compliant and we make that very easy to do. This is a lot of capabilities, but as operators and as you represent the business, what I'll tell you about the core platform, which is the first layer of our capability, is that what we have solved is the ability to deploy in your environment, connect to multiple sources of data at the same time. These could be historians, they could be SAP type systems, ERP, they could be stores of files like your P&ID files or instrumentation files or what have you, maintenance records or CMMS systems, all of the above, in order to create a continuously updated view of the data and then run analytics on top of it, right? So for instance, we're able to say, what was the delta temperature in the outlet valve at the time, within 15 minutes, of a product transition, right? That's a fairly complicated business or SME-specific capability. We make that easy to do within like one line of code or one expression in C3. And once you're able to do that at that speed and pace, you can then scale that up very quickly. For the two other pieces of information that I think are relevant at this level, right? One, we built this so that the system works on any cloud or on-premise environment. So if you have one of these clouds, we can deploy in that. If you have multiple of them, we can deploy in multiple of them, et cetera. And then second, we've made sure that the platform, which is this blue box, has the ability to expose the data consumed in it to business analysts, to developers, to your data scientists, so that you can use all the work that's been done for any additional use cases as well. So you get a huge amount of reusability and scalability as we get into this. The platform itself is designed to scale, which means you're not constrained once we build to only one location or only a certain amount of compute. It's designed to be elastically scalable, right? So elastic scalability, we're flexible on the infrastructure. We're designed to pull in data from multiple places and process them continuously with the goal of serving these up from an analytics and machine learning perspective. What we've done on top of this is build applications, right? And these applications are now full workflow applications, and Laila will show you a couple of them when we get into the reliability suite next. These are full workflow applications that are designed to expose to business users the right amount of insight on anything they're doing. So in the world that we call the reliability suite, that world looks like asset operations and process operations. So in Reliability Suite, we expose this idea of how do you monitor a fleet of assets, different types, different OEMs, different operating settings, while providing a common interface to monitor things, understand why they might fail or exhibit anomalous behavior, what possible root causes are, and what to do about it. Right? All connected into one flow, and I think Sid will show it to you afterwards outside, and Laila might have a video or two. On the flip side, we're also, as you build this asset hierarchy and pull together how you monitor individual assets, we can also watch these assets as a process. So now you can connect up these assets and say, okay, for this process, what are the input and output parameters that matter? And can I learn through an optimization capability if there are set points that can change something, right? Energy consumption, yield, raw material consumption, et cetera. We just went live on a system completely different from yours and strangely similar, sugar production in Guatemala with this capability, where if you think about what they do, they have crushers for sugarcane that extract juice. that then process that juice at different evaporating temperatures based on the sugar content that's dynamically changing in order to get high concentration sugarcane liquid or juice that then they evaporate at certain temperatures to maximize sugar. Every one of those is a chemical process with 4 or 5 set points each. Right? How much water do I put in, at what rate, with what evaporating temperature, with what pressure, in order to drive the process through. And with this, in about 3 months, we were able to prove that A, we can model the system end to end, and 2, we were able to squeeze out about 2 to 2.5% more yield for the same amount of sugarcane going in. Right? Completely different than your world, but at the same time, very strangely similar. Right? Because it's the same type of analytics that you have to do continuously. In the supply chain world, we do a lot of work on watching the end-to-end supply chain, starting with demand forecasting. Right? This is both raw material demand. If I need to make something, how much should I order? As well as finished goods demand. What is the demand function coming from my customers in order that I can better solve for that in terms of production scheduling or manufacturing plans or what have you. What we routinely see when we get into these things is the combination of more data. So we don't just use the ERP data in SAP, but it's much more data than that because we combine it with outage schedules, manufacturing schedules, in some cases promotional activity in a B2C type of environment, et cetera. In a B2B environment, we can pull in data from your sales systems and CRM systems. What deals will I sign in the next 30, 40 days that drive a demand function, and so on, in order to get far more accurate on the demand function. Right? And so we routinely will see a reduction in forecast error by 50 to 60%. When we deploy these systems. We do a lot of work on sourcing optimization. So imagine you buy a lot of things. These look like commodities. These look like chemical APIs, et cetera, pharma APIs. What's the best way to monitor what I'm paying for them vis-a-vis market across all my plants? We do this for Baker Hughes at massive scale. Right? And so all of their manufacturing facilities globally buy similar things, but on independent contracts. We benchmark across all of them continuously and tie that to a best matched industry index. This could be a chemical index. It could be a raw material like iron and steel index, what have you, to see how you're trending vis-a-vis the market and continuously expose that to supply chain analysts. We do a lot of production schedule optimization, very relevant in petrochemical type operations where you're deciding what to make in what sequence and so on. We recently did this for a steel manufacturer in the US where based on the transitions from one grade of steel to the next, the amount of wastage you incur between those transitions or during those transitions can be optimized. So we were able to squeeze out, again, about 2 to 3% reduction in 2 to 3% reduction in the total wastage, but a few hundred, almost 1,000 tons in one plant, right? Of steel that is not scrap steel anymore, but is actually commercially viable. Right? Just by figuring out what the right transitions are across all of these, across all of the constraints they have. We monitor supply networks globally. This is to predict what POs will be late, what shipments to customers will be late. And we do continuous inventory optimization to minimize working capital. Right, so given the demand function, given variability, when I tell the supplier that they've got to send me something, they're always late by 3 days and they're always 80% of what I order. The system can take that into account and optimize automatically. And you don't have to do it on a day-to-day basis. What I'm telling you are all business outcomes, not fancy machine learning talk, because that's what we do, right? We translate what the technology is to actually solve for what is the true business outcome that we drive for. And then finally, we're spending a lot of time now on energy management, and it's a loose term, but it's basically all resource management for processes. So how do you benchmark energy, water, other resources across processes? Look for opportunities to benchmark and optimize them. And at the corporate level, how do you streamline and optimize reporting? Right? And this is part of the ESG function or the sustainability function that we think will gain more and more prominence as we go along. Right? And you see all these things come together. For instance, you might have corporate initiatives to lower the greenhouse gas footprint of the manufacturing facilities as one of the big corporate initiatives we're running. And then the other applications that you see actually do that, like the energy management one. And those are coupled in a way that we can draw from one and use in the next. And the important part here, and I'll stress this again, is there's a huge difference between doing one-off projects on the side just to show that you can do this, to actually deploying these systems at the scale of the entire enterprise, right? All of your manufacturing facilities, all of your production facilities, et cetera. And the next few pictures just give you an illustration of that. At Shell, for instance, we went from doing one location to repeating it across almost 30 locations in very rapid succession, right? Because what we build out the first time around is really around the core schema, ontology, asset hierarchy, connections between data, and then we can use that to replicate very, very quickly. And as we do this, this is hundreds and thousands of machine learning models, hundreds and thousands of sensors, hundreds and thousands of distinct rows of data being processed, millions of rows of data being processed every day. We've seen this at other places as well, and this really gives us confidence and conviction that we're doing this the right way, right? Because remember, for this one thing to finish, it means that you've deployed the system, but also that people are using it, right, in a consistent way. We've done this at the Air Force, and you might think the Air Force is very well run in the US. It's also a lot of different personalities and people and everything else. And so getting 20 different platform is think of a platform as one type of aircraft, right? And that one type of aircraft might be in 10 different air bases across the US or globally. And now think of the complexity of deploying the system across 20 types of aircraft across all the bases in the US, right? That's what and now imagine doing that in a year and a half, right? That's the speed at which we can run. The last bit of our software offering is all things generative AI. And for all of you following this whole thing, it's been a year now, I believe, since Sam Altman launched this thing with OpenAI, got fired, got rehired, everything else along the way. For us, I mean, there's different ways you can look at generative AI. The most simple way is to say, oh, this is a new search interface, and I can throw it up like Google Bard or any one of these tools, ChatGPT, in order to ask questions and do my homework for me, et cetera. Right? And that's fine. Where we see this really play out is in creating a knowledge assistant in these complex business processes that we just went through before. Right? So it's not enough to say, and so really in that sense, it becomes a new form or a new interface between users and very complex systems underneath. So for instance, one of our production systems that we deployed, the manufacturing facilities were seeing a lot of employee retirements. So the most senior employees that actually knew every single knob and every single blinking light were retiring. The new people that were joining were new, and they didn't know enough about really how the system worked. Right? These SOPs were like 500-page binders. It's like, here, read this. I'm like, okay. The telemetry for different systems was like 6,000 different sensors doing various things, and it's tough to take account of everything. the experienced operators were available, but you got to ask the right questions and so on. So what we've done here is really take all of these systems and create a unified view using a generative AI interface. I'll show you a short video after this that essentially pulls all of this together into a single chat-based interface that you can ask questions of for that domain. What types of questions do people ask? Well, it turns out it's actually gets from simple to complex, right? So if I look at the first one, that's what most of these systems do today, document retrieval, right? It's like, give me your documents, I will index everything and keep it all handy, and then you can ask me a question about what is the SOP to change the glass on this particular piece of equipment. Here is the SOP, right? What is the SOP to do something else? Here it is, and so on and so forth. That tends to be a lot of what should I do, very, very basic questions, or why is this occurring? Because you can read failure reports and say, okay, the most common causes for this happening are A, B, C. We call that category 1, right? It's typically text-only based, it's document-based, and it's fairly straightforward. I mean, still pretty complex when you think about it, but fairly straightforward from the state of the art of the technology. What we are also doing now is really everything in blue, right? And the word center line is a pulp and paper example, but really the idea here is, can I also ask the same system what my how my equipment is doing, right? What was the variation in the spool rate versus the min and max that I have set for it? Now that's a far more complex problem because you're asking the system for data and how that data compares to some other data. It's not in a document. It's actually in a OSI Pi historian or a Aviva historian somewhere that needs to be pulled out and processed, along with the set points that are stored in the ERP system, along with an SOP that says don't let the allowable range for these set points is 95% to 105% of the value stored in the ERP. And you're suddenly expecting that the system is able to pull all of that together and then answer the question of, is my system okay? Right? Very, very different than reading text and throwing it back at you. Now, because we've invested in the platform capability that you saw earlier, we're able to answer that pretty quickly, right? Because we're indexing all of these things anyway, and we're able to pull it all together in a way that makes sense. And so, am I within expected bounds? Right? The last time I made this grade of material, what was the max temperature at this sensor? Well, that means I need to go look at my production schedule going back in time to find the first instance of when I made this grade of material today, which I need to know from context. Go pick out the data for that time range, and then say, oh, this is what it was. There's a lot of reasoning that's happening, but it's contextual reasoning as it relates to data. We're able to do that. The last bit which we are working on right now, and the goal is we're on track to go live before the end of the calendar year, is open troubleshooting. So in this case, if you have maintenance flowcharts that say, hey, if you have a problem, first check this, then check that, and if those two things are false, then it must be this issue, go do this. Right? And you have various flowcharts that play out. We're actually programming those flowcharts into the generative AI system. So the system then says, oh, this flowchart is the following. I'm going to actually go check that. So the system then check that, and then check that, and then tell the user, do this because I checked those two things and they're false. Right? Again, very powerful reasoning, but much higher level of reasoning than go look at the document and come back. Right? And that's the state of the art as it relates to what we're doing. The other piece that's important from a generative AI capability, which matters from a safety, security, IP protection, et cetera, is we've done a lot of work to separate and clarify how the system is architected so that we keep company data proprietary, safe, without exposure to other systems, other users, things like that. Right? So a traditional LLM, if you go to Bard or ChatGPT and throw a document in there and say, okay, read this and summarize it for me, what that does is index that entire document into the global corpus of all information, which means it gets blended in with everything else. It's exposed, so anyone else can log in and access it if they get into it. It also, these systems tend to hallucinate, give you random responses. They're forced to answer, right? And so they tend to hallucinate a lot, and you can play with it a little bit. There's also no enterprise access controls. There's information leakage that can happen across the board. What we've done at C3 is we've separated the reasoning engine, the brain, which is the chat interface, from the memory or the data store in a very explicit way. And so when you ask a question of the system, it then asks a question of the data store and only responds if the data store has the relevant information. So we separate the two. And that also allows us to place access controls on that back and forth. And so we're able to control who has access to information and whether they are allowed to access that information or not. We've also expanded it in green up there to all kinds of data. Right? So this looks like tables, this looks like documents, this looks like images, it looks like sensor data, all of these elements. And so what happens then is you get far more deterministic responses. You can control what information is used to answer what kind of question. You get full traceability across why the system came back with a specific answer, which then allows a human to either keep it or disregard it as needed. We can apply enterprise access controls completely, so there's no unauthorized use of information across the board. It also allows us to eliminate hallucination completely. So the system is allowed to and encouraged to say, I don't know. I can't answer that question. I don't know. Right? But here are some relevant pieces of information that you can look at. And we try not to force hallucination in. I mean, we eliminate it almost entirely. Let me show you a quick video that will illustrate a few ideas of that progression from document-based retrieval to telemetry and geospatial querying all at once. If it works, let's see. One more? Yes. So this is a wind turbine demo example, right? How might a wind turbine fail? This looks like documents. It says, okay, a wind turbine can fail due to electrical issues, grid failure, flash fail, or malfunction. Here are all the documents that I've found that allow me to give you that answer. You can look at summaries as you hover over these. And if you want to actually go look at the documents, click through and it pulls up. Right? There's search results and so on and so forth. Now, let's say you wanted to chat and you start something, you wanted to get a little more detailed in this context or in this domain. You say, okay, how do I fix an electrical issue? The system starts processing it. I'll go this side. Ensure there's no breakage. So again, this is document summarization, but it's looking at safety procedures as well as other solutions to say, okay, ensure there's no breakage, then go look at it. And you can provide feedback as you go. Okay, all of this is level 1, document reasoning. Okay, now I might say, what are the GPS coordinates for each wind turbine? Now, there's a very different type of query, right? Because now I have to go to my ERP system and say, okay, here's lat long of everything. And then the system decides, because this is geospatial, I'm actually going to show it to the user, not as a grid, but as a map. Right? And that's baked in as well. And then you say, what was the average daily generator rotation speed for each turbine in January 2022? So this is time and space and telemetry. It'll scroll up a little bit. And here we go. It's actually created a time series of a very specific KPI, generator RPM, for a period of time as you asked. Right? This is not asking an SQL query, but a very natural language type interface. And I think there's one more eventually that maybe this is it. And so you go from, and this is the start of these things, because now you can get into saying, okay, which of these was out of bounds, or tell me the last time RPM was out of bounds, and you know that you can start reasoning through that as well. I think that was it. So just to summarize, I think what we've been in the business of at C3 AI is really building these enterprise AI solutions, right? They combine machine learning with optimization capabilities plugged into real-world business processes. In order to do that, we've built on the back end a very powerful data integration unification capability, as well as a continuous analytic processing capability, as well as visualization. And we then surface that up either through pre-built apps, so reliability suite, supply chain suite, sustainability suite, or in this generative AI interface, or both. And as Lala will show you, we're starting to put those two together now. That's really our business. That's what we do, right? And we obsess as a company about delivering value to our customers. So it's a nonstop conversation about why is this valuable? Are we solving the right problem? How can we tweak it so that it gets sticky and gets used? And that's the nature, and that's what we do. And that's what we do, and that's what we're looking to engage with all of you about. Okay? I'll pause there. If there's any questions I can answer now, happy to do so. Otherwise, I'm around. Please.
Yeah. Good morning. My name is Louis Pruitt, and I work for RW Generation.
Hi, Louis.
Thank you for the presentation. It was very interesting. When you introduce a platform like C3 with a customer, what do you need to put in place to manage the data with that customer?
Yep.
How does it work in practice?
So a very good question. So let me repeat the question, because so I think the question was, when you put in place a platform like C3 at a customer, what do you need to manage the data in that deployment or in that setting? It's a great question, because the important part we emphasize is to ensure that there is minimal disruption with existing data systems, right? So I'll take a technical detour slightly. We deploy C3 in your cloud environment or your on-premise environment, right? So firstly, we don't expect that your data leaves your world, right? So just from a very high level, IT security, like it's all staying inside RWE, right? It's not coming out. And equivalently for all of you. Within that, we then ask the second question, which is, have you already aggregated this data into something that looks like a data lake or some unified view? If that is the case, we can connect to that and use it. If it is not the case, then we can connect to individual systems, like SAP instances or anything else, in order to pull all of that together as well, right? And there's a series of things we work through with IT security and information security to create all of the permissions needed to do that. But at a very high level, we bring the software to your environment, so data does not leave your world. From an IP and data perspective, we don't take ownership of your data. You own your data. You own all the products of your data. So all of the insights, all of the predictions, all of that is all, we don't ever take ownership of that. And all of the data we try and minimize replication of that data as much as possible. It just depends on what we're doing, but that's kind of the idea. Did that hopefully answer your question?
Partly.
Please.
The quality aspect of those.
Oh, yes. OK. So let me take that. So the other piece of this is everyone's worried about the quality of their data, right? And I always assure people, it's like your data are as bad as everyone else's, right? Like it's as bad as everyone else's, right? It's the same issues that you find on fat fingering some sensor data and you get 3 extra zeros, to the pi tags being wrongly coded, to files being mislabeled, to referential data being broken, like standard, par for the course. What we do in C3 when we ingest or process data is we look for what we call referential integrity, right? And so as we process the data in, we're checking for both whether things refer to each other, and we can force that relationship in. So it checks for it and says, hey, I can't find a match here, what should I do? We also have quality controls as the data come in. So if we find anomalous values, we can ignore the value. We can replace it with the closest alternative that keeps things smooth, right? And so on. So there's a lot of quality controls as we process the data. If you do those two things well, referential integrity and then quality as you ingest, it solves like 95% of data problems, right? Just fundamentally. There will always be some quirks that come up, and we'll deal with those as we do. So the other piece we do when we do predictions is we attach. So let's say you make a prediction that's dependent on 10 things, right? And you need each of those 10 things to be there, and then the machine learning model processes those 10 values and spits out a number, 75% likelihood of failure. We're able to contextualize that 75% alongside the availability of that data for that particular prediction. So we can say, look, the prediction likelihood of failure is 75%, but the data availability to make that prediction was 3%. So don't trust it, right? And on another case, it's 75%, but it's 95% available. You should feel good about that prediction and work on it. And we can show that to the user, which is very powerful because now you can actually make those decisions seamlessly. And so just various things we've done over the way because of exactly these issues. So, absolutely. So hopefully that gives you a little more color.
Thank you.
Please.
Yes. My name is Anna Maria, and
Hi,
I
Maria.
come from the more independent space. I don't work for a large company. I have been running my own smaller company in telecom for the past 20 years.
Excellent.
So my question is, how, in order to implement this very dynamic platform, what is the smallest size of a company? For example, can you get a return on investment if you implement it in a 50 million per year revenue company? Question number one. And question number two is, how do you actually measure success? Because we all get excited about ChatGPT-4, for example, and Claude 2. I do. But I end up staying up at night, every night, and actually I'm becoming, yes, but with good things, but on the other hand, becoming less efficient with other things because I'm so preoccupied with managing my new tasks.
Yeah.
And I imagine the same thing happens in corporations. Maybe you say goodbye to some people, but you become busy with other areas. So how do you actually count success, and how soon do you count the success? Do you count it in 6 months, in 2 years? Those are my two questions, because those would be
two very valuable questions. So let me just unpack them one by one. How small or large do we need to be in order to gain value? You know, it's a great question. I think the system itself is designed to be scalable. So we can go small or large depending on how, what kind of data we need to process and so on and so forth. In many of our cases, especially at the early stages of our deployments, we tend to make it so that there is a very low barrier to entry. It's like, let's just prove that this works, and the value you generate is commensurate with the cost of it. So it's not designed to be a very high fixed cost kind of game, right? When you get to the scale that's on the other end of that spectrum, then it's a different story because you're dealing with massive footprints across the board. So I don't think we would say that there's a minimum bar or maximum bar kind of thing. It's more around, is there business value that's in the tune of about a few million euros a year, right? And if that makes sense, then the ROI works out. If you're chasing like tens of thousands of euros a year, then we'd say, okay, you can do that with simpler tools, right? So that's really the question to ask. And that's an important consideration, because in many cases, our deployments, while they may be in large companies, they will start with one asset, which will look like exactly that size, right? It's not, and so the question is not, it's like, hey, what's the value we expect to get as we get into this? Your second question is actually tied to then, so if you believe that, then the question becomes, how do you realize that value? And for us, we think of this as a few different things you have to watch and measure, and we try and bake these into these applications, right? One is scale, right? Are you watching one piece of equipment or 100? right? So that are you maximizing the footprint against which you can deploy the system? 2 is usage. Are people logging in and using the system across the board? 3 is machine learning or optimization outcomes. So this is, am I able to predict an equipment failure? Am I able to generate recommendations that make sense to an experienced operator? And we track that using feedback in some way, right? And so this is, you can track machine learning capabilities like precision and recall and those kinds of measures, but you can also track it based on user feedback, right? What fraction of the recommendations that were generated were reviewed and adopted? Right? Is a pretty strong measure of how good the system is in terms of actual use. And then 4th, we look at some operational KPI that should move. So for instance, over time, as you deploy the system, are we seeing fewer and fewer trips? Are we seeing fewer and fewer excursions that are unnecessary? Are we seeing fewer and fewer, or are we seeing yield improve for the same type of product over subsequent months across the board? We at C3, we don't directly, we will put a number to it, but we don't. Eventually, the idea is to get to economic value, but the sequence is always scale, usage, machine learning outputs and value, business KPIs moving, and then if the business KPI moves, there is some value there. Right? And so we try and tie those together. And a lot of this we can bake into the application, because I can track usage, I can track scale, I can track machine learning results. I can, in many cases, track operational KPIs.